Good day, everyone. I welcome you all to this session. In this session, we are going to be looking at factors and highest common factor. This topic is very simple, and I'm going to make it more easier for you. First of all, what is the meaning of factor? What are factors? A very short definition. A factor of a number A factor is a number that can be used to divide a given number without a remainder. Yes, a factor of a number is a number that can divide that very number without leaving a remainder. The definition is somehow corny. Let me explain to you what I'm talking about. If we are looking for the factors of 12, the factors of 12 are those numbers that can divide 12 without leaving a remainder. Are you getting the explanation now? So the numbers that can divide a given number or a certain number without remainder are what we call factors of that number. So for example, in 12, the first number is 1, right? 12 divided by 1. You can check it in your book. 12 divided by 1. Is it going to give you a remainder? No. 12 divided by 1 is 12. Remainder 0. Therefore, 1 is a factor of 12. 12 divided by 2. The same thing. 12 divided by 2 gives you 6. Remainder 0. Therefore, 2 is a factor of 12. Check the next number. 12 divided by 3. The same thing. 12 divided by 3 gives you 4, remainder 0. Therefore, 3 is also a factor of 12. 12 divided by 4, we also have the same thing. 12 divided by 4 is 3, remainder 0. Therefore, 4 is also a factor of 12. Now, 12 divided by 5. You discover that 12 divided by 5 leaves remainder of 2. Therefore, 5 is not a factor of 12. 12 divided by 6 gives you 2, remainder 0. Therefore, 6 is a factor. 12 divided by 7, no. It will definitely leave a remainder. 12 divided by 8 leaves a remainder. Divided by 9 leaves a remainder. If you try it onward, you discover that after 6, the next number that can divide 12 is 12. So the last factor of this 12 is going to be 12. So 12 is going to be the last number that can divide 12 without a remainder. Yes. So this is how we look for factors. We can look for the factors of, the factors of 5. What are the factors of 5? Remember, all numbers can be divided by 1. Therefore, when you are looking for the factors of any number, have it at the back of your mind that 1 is always there. Now you check the next number, which is 2. 5 divided by 2 will give you a remainder. 5 divided by 3 gives a remainder. 5 divided by 4 gives a remainder, except 5 divided by 5. It means the factors of 5 are 1 and 5. Therefore, all number has at least 2 factors. There is no number that does not have at least 2 factors, because every number can be divided by 1 and every number can be divided by itself. 5 divided by itself gives you 1. 5 divided by 1 gives you 5 itself. So that means all numbers have at least 2 factors, except 1. 1 is a very special number when it comes to this. 1 has only 1 factor, which is 1. So it's special. Apart from 1, all other numbers has at least 2 factors. This now leads us to the types of factors. In this topic, we are going to be needing common factors. We will be needing common factors and prime factors. What are common factors? What are prime factors? Just as we know, when we were dealing with common multiples, those of you that watched the previous video on LCM, you discovered that we also had common multiples. The same thing happens here in common factor. So common factors are factors that are being shared by 2 different numbers also. For example, here, what are the common factors? You can see we have 1 here and we have 1 here. So 1 is the only common factor we are having here. We don't have any number that is here and here again. So this is what common factors talk about. So highest common factor, the procedures just follows the LCM procedures. The only difference is that instead of factors, instead of multiples, in this time around it's going to be what? Factors. So let's now look at these prime factors. What are prime factors? For us to know prime factors, we must first of all know what is the meaning of prime. What is prime? When you hear the word prime numbers are numbers that have only 2 factors. Remember I told you that the smallest amount of factor a number can have is 2. No matter how little the number is, the number must have at least 2 factors, except 1. So prime numbers are numbers that have at least 2 and only 2 factors. It does not have more than 2 factors. A good example is this 5 that we just wrote here. It has only 2 factors. Another example is 3. 3 has only 2 factors. 3 can be divided by 1 and it can be divided by itself, 3. Another example is 7. 7 can be divided by 1 and 7. So you can see prime numbers have only 2 factors, 1 and itself. So prime numbers are numbers that can be divided by only 2 numbers. They can be divided by 2 and only 2 numbers, which is 1 and itself. So there are several numbers like this that are prime numbers. If you have been taught prime numbers before, you are supposed to be familiar with those numbers, like 2, 3, 5, 7, 11, 13, 17, continuously 23, and all of that. At least you should be able to memorize the first 20 prime numbers in case of when you are going to be needing it. Okay, so this is what prime numbers means. Now when we now relate it here, prime factors, when we now put them together, prime factors, what does it mean? It means prime factors are factors of a number that is prime. So for us to know prime factors, we have to know prime numbers very, very well. We have to know the prime numbers very, very well. Therefore, I'm going to write a short list of prime numbers on the board for you right now. Yes, and I will need you to pause the video. Yes, you pause the video and write it down so that you can study them later. Or maybe you have a list somewhere else before. So examples of prime numbers. We have 2, we have 3, we have 5, we have 7, we have 11, we have 13, we have 17, we have 19, we have 23, we have 29, we have 31, we have 37, we have 41, we have 43, we have 47, and so on and so forth. Yes, so there might be an error somewhere. Make sure you check through. So these are examples of prime numbers. Know them. So the basic ones that are much more important for us in this topic are those first ones. This first line of prime numbers up to 20 is very, very important that you know them for you to be very good at this topic, because sometimes in this topic you have to use prime numbers very well. So master these first prime numbers. The rest you can actually generate them on your own. You just have to be dividing each number and see which one has only 2 factors. But this one you are supposed to know it in a reflex way. The moment you hear these numbers, you should know these are prime numbers. So prime factors are factors of a number that is prime. For example, let us write the factors of 20. Factors of 20 are what? Numbers that can divide 20 without a remainder. For example, 1, 20 divided by 1, it can actually go. 20 divided by 2, 10 remainder 0. Divided by 3 is not possible, there will be remainder. Try it and see. Divided by 4, we get 5 remainder 0. Divided by 5, we get 4 remainder 0. Divided by 6, there will be a remainder 3 remainder 2. Try it. Divided by 7, there will be a remainder. Divided by 8, there will be a remainder. 9, the same thing. 10. Divided by 10 is 2, no remainder. Try 11, there will be remainder. 12 remainder. 13, 14. So the moment you get to half of the number you are looking for its factor. For example, half of 20 is 10. The moment you get to 10, the next thing you should do is to do what? Just move to the last number, which is that same number. So the last number that would be able to divide 20 is 20. Yes. Now, what are the prime factors of this number? The prime factors of this number are those factors here that are prime numbers. You see what I'm talking about? If you don't know what a prime number is and you don't know which one is prime number, you won't be able to look for the prime factors. So we already know our prime number. 2. Is there 2 here? Yeah. You see that? 4. Is 4 a prime number? No. 5. Is 5 a prime number? Yes. Prime number. 10. Is 10 a prime number? No. 20 prime number? No. So the prime factors now are what? 2 and 5 only. 2 and 5 only. Is that taken now? So what we have said so far, what are factors? Factors are numbers that can be used to divide a given number without leaving a remainder. Yes, factors are numbers that can be used to divide a given number without leaving a remainder. The factors of a number are those set of numbers that can be used to divide the number without leaving a remainder. And I said we have 2 different types of factors we will be focusing on for the sake of this topic. The first one, which is common factors, which are the factors shared by a group of numbers, common between them. And the second one is prime factors. And I told you for us to know prime factors, we must be able to understand what prime numbers are. And we said prime numbers are numbers that have only 2 factors. They have 2 and only 2 factors, themselves and 1. Therefore, with that explanation, we now knew that prime factors are factors that are prime numbers. Just like the example we gave, I asked you to study these prime numbers. That's why I said you should learn at least the first set of prime numbers between 1 and 20. After you are able to learn it, when I ask you to look for the prime factors of a given number, the first thing is to list out all the factors of that number and then circle out the numbers that are prime amongst the factors. Like for example here, we have circled out 2, which is a prime number, and 5, which is also a prime number, as the prime factor of 20. Is that taken? So this is the first step. Now let's move into the highest common factors. We just did factors. Yes. Let's now go to highest common factors. I need to wipe the board. Alright, highest common factors. Highest common factors. Now, in our LCM, if you remember, you watched the video really well, we said lowest common multiple is the smallest number that can be divided by a group of number without a remainder, or is the smallest number that can be divided by a set of number without leaving a remainder. But highest common factor, remember then is lowest common multiple, lowest, smallest. Now highest common factor is the highest number that can be divided by a set of number without a remainder. Yes, let me show you how we solve it. I'm going to be showing you, say, 2 different methods or 3 depending on our timing. Let's take a question. Okay, the question says, find the highest number. Remember, the moment you see lowest number, just know it's LCM. And when you see highest number, just know that it's highest common factor. Find the highest number that can be divided by 8 and 12 without leaving a remainder. What they're asking us to do is find the highest common factor of 8 and 12. We are going to go for the first method. We are going for the first method, which is the listing method, just like in LCM. Remember, in LCM we also had listing method. Now we'll go for the first method, which is the listing method. In listing method, what do we do? In the LCM, we are dealing with multiple. Then we write out the multiples first, then we go to the common multiples before we now go for the lowest common multiples. But for the HCF, we write the factors first, then we write the common factors, then we go for the highest common factors. So first of all, we are going to write the factors. Okay, we first of all write out the factors of 8 and 12. What are the factors of 8? The factors of 8 are those numbers that we can use to divide 8 without a remainder. Okay, the factors of 8 are the numbers, the group of numbers we can use to divide 8 without remainder. And also the factors of 12 are the numbers, the group of numbers we can use to divide 12 without remainder. Let's go for the 8. 8 divided by 1, I told you the first factor is always 1. So 8 divided by 2, is it possible? 8 divided by 2, is it possible? It's possible without a remainder. Therefore we write 2. 8 divided by 3, is it possible? It's possible, but there will be a remainder and we don't want a remainder. Therefore 3 is not possible. 8 divided by 4, it's possible, so we write 4 without a remainder. 8 divided by 5 is not possible. 8 divided by 6 is not possible, there will be a remainder. 8 divided by 7 is not possible. 8 divided by 8, which is the last one. Remember what I told you, the moment you get to half of the number, half of 8 is 4, just go straight to the last number. So these are the factors of 8. Now let's go for the factors of 12. The numbers that can divide 12 without a remainder. The first one is always 1. The second one is 2. Right? 12 divided by 2 is 6. Remainder 0. 12 divided by 3 is possible without remainder. 12 divided by 4 is possible without remainder. 12 divided by 5 is not possible. Is it? It's not possible. 12 divided by 6 is possible without a remainder. And we have gotten to half of the number. So the last one is 12. So we have written down the factors of 8 and 12. Just like the way we write down the multiples of what? Numbers before the common multiples. Now it's time for us to now pick out the common factors. What are those factors that we can see here and we can see them here? That is what we are going to write out now. Common factors. What are the common factors? We can see 1 here and we can see 1 here. Therefore, 1. We can see 2 here and we can see 2 here. 2. We can see 4 here and we can also see 4 here. I think that is the last number we can see. Therefore, it's 1, 2 and 4. That is the common factor. And here we now go for the last one, which is the highest common factor. Highest means the biggest. What is the biggest number amongst these common factors that we listed out? Obviously, you all know the biggest number here is 4. Therefore, our highest common factor is going to be equal to 4. As simple as this. Just like the same steps we followed when we were solving LCM. Look for the multiples, look for the common multiples, and then look for the lowest out of the common multiples. The same thing we do here. You look for the factors, you look for the common factors, and you look for the highest out of the common factors. The only difference here is that you are dealing with factors and you are not dealing with multiples. So in multiples, you are looking for a number that can be divided by those group of numbers. But in factors, you are looking for the number that can divide that number without a remainder. So a little bit differences. You just have to focus well, look into it again, and get the pattern. So let's go to the next method. Another method I want to show you is prime factorization. Prime factorization. Let me try to, will my space be enough? I think I have to clean. You might not be able to see what I'm writing at this side of the board. But you can just note it down. Our answer was 4, right? Our answer was 4. Yes, let's now use prime factorization method. In prime factorization method, you break down the numbers. The numbers you are looking for, the highest common factors. You break down those numbers into what? Prime numbers multiplied together. For example, one thing you should know about prime numbers, they are very, very special numbers. All numbers are being gotten, they are being built from prime numbers. You say prime numbers are the building blocks of all numbers. Yes, prime numbers are the building blocks of all numbers. There is no number we cannot multiply prime numbers to get. For example, look at our prime numbers. Look at what I'm talking about. If these are our prime numbers, these are examples of prime number. There is no number you are going to give me that I cannot multiply by these numbers to get. If you say 2, I can get 2 from here. If you say 3, I can get 3 from here. If you say 4, I'm going to do 2 times 2 to get the 4. If you say 5, this is 5. If you are looking for 6, we say 2 multiplied by 3 to get 6. Okay, 7 is here. If you are looking for 8, you say 2 multiplied by 2 multiplied by 2. You get it. To get 8, you say what? 2 multiplied by 2 is what? 4. 4 multiplied by 2, 8. So this is the same thing as 8. To get 10, we say 5 multiplied by 2. To get 11, it's here. To get 12, you say 3 multiplied by 2 multiplied by 2. Look at it. 3 multiplied by 2 is 6. 6 times 2 is what? 12. To get 14, you say 7 multiplied by 2. To get 15, you say 5 multiplied by 3. Are you seeing it? To get 17 is here. To get 18, you say what? 3 multiplied by what? 3 multiplied by 2, that is 6. Multiplied by 3 again. For example, you say 3 multiplied by 3. 3 times 3 is 9. 9 times 2, 18. So there is no number we cannot construct with what? Prime numbers. We can break the numbers down into prime numbers. That is how we are going to use this prime factorization. But we must know the methods to use. Just knowing that prime numbers are the building blocks is not enough. I think I have to write the prime number somewhere here so that you can be seeing it for the purpose of this class. So these are examples of prime numbers and we are going to be using it. Now we are looking for the highest common factor of 8 and 12. What we do is we have to break these numbers down. We have to break it down to what? Prime numbers. First of all, we are going to check, can we multiply 2 to get 8? Yes, of course, we can multiply 2. 2 multiplied by 4, right? 2 multiplied by 4 is 8. So 8 is the same thing as 2 multiplied by 4. And remember, 4 is not a prime number. We want to express this 8, we want to change this 8 to a prime number. So how do we change this 4 to a prime number? We can change this 4 by saying 2 multiplied by 2. Remember, the only numbers we want to see are those prime numbers. So we are going to change this 4 to 2 multiplied by 2. And therefore here you are now going to be having your 2 multiplied by, this 4 is going to be changed to what? 2 times 2. And now we have converted this 8 into what? Prime numbers. The same thing, we are going to convert the 12 into prime numbers. We can also convert the 12 using 2, which is 2 multiplied by 6. And 6 is not prime number, and we don't want to see any number that is not prime here. Therefore, we are still going to change this 6 again. How can we change 6? We can get 6 by doing 2 multiplied by 3. So we are now going to have our 2 times, this 6 is going to change to what? 2 times 3. So now be 2 times 3. So the moment you are able to break your numbers into prime numbers like this, then you are almost done. The next thing now is to see how many numbers can you match together. How many can you match together? Whichever number you can match together, you bring it out and you multiply them together. Simple. So the first thing now, look at it. Our 8 is what? 2 multiplied by 2 multiplied by 2. And our 12 is also 2 multiplied by 2 multiplied by 3. So we are going to bring out 2 and 2. They are the same. The numbers you are going to bring out must be the same. So we bring out the 2. Do they still have something that they can share, slash out? Yes, they still have another 2 and 2. It's now going to be multiplied by 2. Can you slash 2 with 3? No, they are different numbers. You can only slash the numbers that are the same. So 2 times 3, they are not the same. So our answer is going to be 2 multiplied by 2, 4, which is the same 4 we got before. So I'm going to do a quick example with a different number entirely using the 2 methods. And as I'm solving, I'm going to be cleaning. This is just like a revision of everything we have done in this class. Let's use a number like 10 and 20. The question has been changed automatically. 10 and 20. Using the listing method, we first of all look for the factors. Right? Factors of 10 and factors of 20. The factors of 10 are those numbers that can divide 10 without a remainder. And examples of those numbers are 1, 2, 5, and 10. These are the numbers that can divide 10 without remainder. Any other number you think of is going to give you a remainder. So in 20, what are the factors of 20? Numbers that can divide 20 without a remainder. 1 is there, 2 is there, 4 is there, 5 is there, 10 is there, and 20. You can cross-check all this. If you are good with your multiplication table, it's going to help you very well in factors. Because factors, any number you can multiply to get that number is a factor of that number. For example, we can multiply 2 to get 10. 2 times 5 gives us 10. That makes 2 a factor. 5 times 2 gives us 10. That makes 5 a factor. Can you see 4 times 5 gives 20, therefore 4 is a factor. 5 times 4 gives 20, therefore 5 is a factor. Any number you can multiply to get the number is a factor of that number also. So your multiplication table goes a long way. The next thing is the common factor. We look for the common factors. What are the common factors? The factors we can see in both lines. We see 1, we see 2, we see 5, and lastly we see 10, which is and 10. So the next thing now is our highest common factor. Which one is the highest here? Obviously is 10. So the answer is supposed to be 10. Now let's go and check using our prime factorization method. Okay, let's now check using our prime factorization method if we are going to get the same answer. 10. Remember what I said, we are going to break it down into prime numbers. We can get 10 by using 2. 2 multiplied by 5. Yes, this is okay because 5 is a prime number. So we don't need to break 5 down. It's already a prime number. So these are the prime factors that we can give to 10. So let's go to 20. 20. We can actually do 2 multiplied by 10. 2 multiplied by 10. Now this 10 is not a prime number yet, we still have to break the 10. Therefore we have 2 multiplied by, how do we break 10? We can break 10 into 2 times 5. 2 times 5. Therefore 2 times 5. And everything has now turned to what? Prime numbers. The next thing is now to factor out the things that we can slash out together. Here we have 2 and 5, and here we have 2, 2, 5. First of all, they can bring out 2. Both of them brings out 2. They can also both bring down 5. This one doesn't have anything to bring again. Although this one has 2, this one doesn't have 2. Therefore, that's all. Just 2 times 5. This one has 2 and 5. This one also has 2 and 5. We just multiply it and we get our answer again, 10. So whichever method you use out of these two, you are going to get your highest common factors. There are other methods, but for the purpose of this class, let's just focus on these two methods. Thank you very much for listening to me till the end of this class. I will be seeing you in the next session. Bye.